All right, hello. We are doing more dynamic programming today. Yeah, this one's actually on Leetcode. God bless. And yeah, so let's get into it. We're doing partition equal subset sum. Given a non-empty array nums containing only positive integers, find if the array can be partitioned into two subsets, such that the sum of elements in both subsets is equal. Yeah, I guess going into this one, being able to separate this into two equal ones is possible if you have 1, 5, and 5, and then the 11 on its own. Well, I guess there's an explanation. I don't know why I did that in my head. And this other one, it's false because it's not possible. You have a sum of 11. You can't divide that by 2, so it fails. So yeah, with that being said, let's get into it. We'll have a total sum equals sum of nums. This gives us the sum of every element in the array, right? And then so if total sum is odd, return false. We want to do this because if total sum is if it's odd, then there's no way we can divide it in 2 and then find an equal sum, because that just wouldn't work. So, and it's because these are all integers. If it was floats, potentially possible, but that would also make the problem a little bit harder to do. But yeah, without further ado, let's get not without so yeah, but that's a question for a different time. I don't even know if that's a question that anyone would really ask. But with that, so we'll just skip that idea for now and we'll just get into the rest of this problem. And so we're going to have n is equal to the length of nums, so that we know how long the length is, and we don't want to keep recalling the length of nums. So we're going to store in a variable. We're going to have a variable called subset sum, which is total sum floor divided by 2, because if you only divide it by 2 like this, it gives you a float, and you can't create an array with it or index into an array with it. So you have to floor division it, even though we already know it is even. You need to do this in order to make it into an integer. Just like yesterday, we're going to be creating a two-layered what is it? Two-layered array, 2D array, 2D array. Because we're doing bottom-up programming, that's just what I'm comfortable with. So for every index, we're going to be creating everything with false in the range of subset sum plus 1, because we want to go that extra 1 so that we can actually hit the subset sum. And then for y in range of n. You could also do for y in range of n for to have that extra buffer layer, but for this problem, I personally believe we don't need it, so we won't do n plus 1 here. For I in range of n, we're going to set dp I of 0 to true, because to make a sum of 0, regardless of what our subset is, we are always able to make that sum. So we don't really care. So we want to make it true, just so when we do our bottom up and we're checking the previous cases, we can check for if the number happens to be perfectly equal. We can just set it equal to true. So for I in range of n again, but this time we're actually going to be filling in the rest of our array. For j in range of 1 to subset sum plus 1, we're going to be filling in the array. So if nums I is less than or equal to j, then we're able to do subtraction and then check a previous, like a smaller sum, to see if that is true. And if that's true, then we can make the current value true, right? So we're going to do dp sub I sub j is equal to dp of I minus 1 j, or dp of I minus 1 j minus nums I, because you want to reference. So actually, if I were to draw this out, we have for this. Actually, well, I'll do an easier example, because it's just easier. So I'll have a row for 1, 2, 3, and 4, right? And we're going to have false, 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 and false. So here we have 0, 1, 2, 3, 4, 5. Right, we're going to be using numbers 1, 2, 3, 4. You can divide this into 2 because 1 and 4, 2 and 3 make 5. Right, and so this is our subset sum, and I'm just gonna fill in the rest of this. I can't type for the life of me, I guess. So yeah, we have this, right? This is what we're gonna create first. We're gonna set everything here to true, and then so we have everything to false, right? So in this case, so we'll fill out the first one. We can make one true, but everything else is false, right? So for here, make this true, and then this, since it's equal to j, since 2 is equal to j, we want to take what is it? Oh, so we want to take whatever's above. I guess in this case it would work too, right? So we want to take whatever's above, or j minus the number. So, oh wait, it's only for this one actually, not for this one, because I forgot it's compared to j, not the actual number. I don't know why. So this is j, 2 is equal to that. So we can check the one above, which is false, right? That's the one above here. And this one, we take the j minus the number, so 2 minus 2 is 0, so we go above and to 0, so that's true. So now this actually becomes true. And then for all of these, you can check. So for 3, we take 3 minus 2, so we check the one above and to the left 2, so that's also true. So 3 also becomes true. 4, we check this is false, and this is false, and the ones above are false, right? So that's how we get this, and that's why we need to do this like this. And so if we were to do the else statement, it's where dpij is equal to dp I minus 1 and j. Because you don't, this means that number is, the current number that we're looking at is greater than j, so we can't do the subtraction thing because it'll take you into a negative index. And with Python, even though it is possible, it'll take you like to an undefined, essentially. Like you don't know exactly which index it'll take you to, so that's actually not good. So we just wanted to have that like safe checking in a sense and leave that out. So we can actually continue to trace the rest of this. So for 3, you just take whatever's above for all the numbers before you actually hit 3, and 3 you can take whatever's above. Since it's an OR, we'll just take the true anyways. And so for 4 minus 3, so you'll go to 1, the one above, and go to 1, so this is true. And then for 5 minus 3 is 2, so you go to the 2, that's true, so you take that, because you also OR with the ones above, and that's that. And so regardless, even if this is this never becomes true, even though it will, all of our cases include this where we're checking the one above, so we can actually just go straight through, and then we return this last index here, return dp of n minus 1 and subset sum. So I guess theoretically, if you wanted to just return n here, you could do n plus 1, and then you could also just make this, instead of for everything, you can just make it, actually you can still do it for everything and just go straight down, right? I guess you don't have to do a for loop to set everything. You just have to set the first one, because once you go to the second one, or like the second one, you just check the one above, which will always, we'll just set everything true anyways. But since we just do range from 1 on, you don't have to worry about that one really. Or you realistically could just still not set all of these. Actually, no, you probably should set all of these. Yeah, just set all of these. So let me remove all of this. We need to make this n minus 1 because we don't want to do this. So yeah, you want to set all the things to true in the very beginning as like the edge cases. You want to go through n, you want to go from 1 to subset sum plus 1, and you do all this edge checking, and then you return the very last number, the bottom right index. And when you run the problem, you get a successful solution. Boom. There we go. Alright, so that's how I would do this. What is this problem called again? Partition equal subset sum problem. Yeah, so thanks for watching.